I will talk about video anomaly detection for industrial equipment with multi-pattern repetition. This is today's content: background, method, experiment, result, and background to introduction of time information, and method, experimental result, summary. This is background. I work at IRII, Industrial Research Institute of Ishikawa. The IRII mission is the technical support for local companies. And local company needs at the production site do not want to ship defective product from the factory. Produce the product and then inspect the appearance later. Inspection using still image anomaly detection. Initial method we try initial method is classification is performed by training a large number of normal images and a large number of anomaly images. There was an issue. A large number of anomaly images is difficult to obtain. Then solution method is detect anomalies in still image by having the AI learn to generate only the large number of normal images. That is good. That was good. As a more advanced situation, it wanted to detect unusual operation in industrial equipment that performs repetitive operations. We are developing condition monitoring method using video anomaly detection. The target anomaly is timing anomaly. Timing anomalies are anomalies that cannot be determined from the single still image alone. This is a button pressing robot, for example. Press A button and B button, C button, D button. This is normal condition. But timing anomaly is like A and B and C and C. This is a timing anomalies. But can be determined by considering the regularity of temporal changes in moving images, for example, a sequence of still images. Method of timing anomaly detection. This is conventional method. Let AI learn videos which continuous still image during normal operation and have AI predict and generate the next image at a certain moment. This is how to train. Yes. Input continuous still images A and B and C, then AI generates some images. And loss function set to difference of two images. Then when the video is input, the next image is predicted and generated. AI can generate first just a random image, but AI can be generate next D images. And how to detect is here. A and B and C image input to AI. The AI generate D images, but come from the C image, then AI judge as anomaly when difference is large. This is different image. Then AI can judge that is anomaly. In addition to the conventional method 1 mentioned above, conventional method 2 and conventional method 3 have been proposed. These are proposed method. But issue of conventional method, multiple pattern normal operation. Case of A button A and C and D and A repeated. And the other pattern 2 is A and C and B and A. This is pattern 2. Oh, this is a large issue. AI generate like overlapping image D and B. AI don't know which pattern. Then AI generate overlapping D and B images. Even under normal conditions, there is a large difference from actual image at branch point. This is a branch point. Unable to detect anomaly due to large difference between normal and anomaly conditions. And the purpose of this research is anomaly detection even when there are multiple patterns of normal operation. I will explain conventional method to calculate the anomaly score by difference between the AI generated image and the actual generic image and actual image. At a branch point, the pattern, the difference becomes large even through the operation is normal. AI generates this image and is very different from two images. Then normal operation, but the score, anomaly score is large. Proposed method, our proposed method 1 is here. Anomaly score is calculated based on the difference in latent variables. The difference is smaller at the branch point of the pattern if the operation is normal. Image is different, but latent is similar. And next proposed method, with time. Using time information, the network is robust to missing image frames and efficient processing can be performed at high speed using multiple PCs. First, I explain about this without time method. How to calculate latent variables using autoencoder. Autoencoder is a network that compresses an input image, compute latent variables, in which image features are condensed, and reconstruct the original image from these latent variables. In this study, AE and LSTM are used together to predict the latent variables of the next image of continuous image. Running on the large amount of normal data can bring the coordinate of latent variables corresponding to each image closer together. Image is just a difference, large difference, but 80-dimensional coordinate of latent variables, these three are close to by running. That is the key point. Detailed proposed method, AELSTM. Continuous input image are encoded by encoder into continuous latent representations. These latent representations are sequentially fed into an LSTM. The LSTM generates latent code that are subsequently decoded by a decoder to produce output images. And we calculate difference of images, but difference of latent is loss function. And LSTM div Z. For the AELSTM network, we propose AELSTM div Z, which further divided the latent variable Z into 4 parts and weight them differently. Weight is 0.1, 0.01, 0.001, 0.0001. The evaluation was performed on this network. And next proposed method 2 is PredNet L6, model with up to 6 layers of PredNet. PredNet is used any number of stacked units that combine CNN and LSTM to generate predictions for the next image. And this is the PredNet L6 model. I will explain experiments, how to create continuous image for evaluation. Create a machine that operates in 2 ways. Pattern 1, left rotation, and pattern 2, right rotation is green explained. The data normal rotation. And 15 rotation each for total 100 rotations. And test data, 5 rotation each for total 10 rotations. Test data, anomaly rotation. This is anomaly rotation. 5 rotation each for total of 10 rotations. Anomaly rotation is a speed drops to half during the rotation. I will show these videos. Like this. This is, I create this writing. This is right rotation and right rotation. This is left rotation.
Can you share the whole screen because it's not seen when you put.
Oh, okay.
Just stop share and share small screen.
Oh yeah.
In order to see.
This is a slow rotation. Is anomaly. Software sharing.
And go again to sharing. This is screen, yeah?
Yeah.
Okay. When you have links, is it okay now?
This right turning rotation, and this is right rotation. And next, right rotation. This is test for image for test. I will show a result. Proposed method 1, AELSTM div Z. This is anomaly score and test data. First, normally working, then small anomaly score, and after the anomaly moving, high anomaly score is presented. And this is ROC curve. Yeah, ROC curve is here. And we calculate AUROC. Then AUROC is 0.864. This is a good score. Reference conventional method 1 is 0.7, 2 is 0.39, 3 is 0.08. And proposed method 2, PredNet L6. This is more good, more better the score. We calculate this ROC curve, and AUROC is 0.902. This is better than that. I will show precisely result. Proposed method 2 PredNet L6. I will show images. Left image is actual image, and next is generated from AI images. Next is difference of 2. And this first blue bar is anomaly score of conventional. And next blue bar is anomaly score of proposed. Then I will show. Here is a branch point, and AI can't don't know right turn or left turn. Then really actually left turn, but AI can't 全然違いますね。AI don't, which is then overlap to images. And next, AI know this is start to left turn. Then AI can generate normal, good images and rotating, actually left rotating, and AI can generate same images. Next branch point is here. Actually, right turn is started, but AI don't know that. Then AI generate only overlapping images. And next time, AI can generate right turn images. Then, conventional method is, this is normal working, but conventional method is calculate high anomaly score. But we propose method is low anomaly score. This is our result. Oh, this is overlapping images, and next AI can generate good images. Okay, this conventional anomaly score is no good, and our proposed method is very good scores. And next, we propose. I explain about proposed method with time here. Background. We also evaluated the introduction of time information. The merit of introducing time information are these. Merit one is robust to missing image frames. Merit two is efficient processing can be performed at high speed using multiple PCs. First, we discuss these merit. Merit one, robust to missing image frames. When continuous still images are sent via network communication, missing image frames often occur. Oh, sorry. When continuous still images are sent via network communication, missing image frames often occur. This is usually not a problem if human is only watching the video. But when AI detects anomalies, missing image frames are misjudged as anomaly event, through they are normal. This is. On merit two, efficient processing can be performed at high speed using multiple PCs. At now, the processing speed is about 4 FPS, no GPUs, which is not fast enough. Therefore, by using multiple PC to distribute the captured frame and have them processed, the overall processing can be done at a higher FPS. Only one AI can process 4 FPS, but two AI can process 8 FPS. If 100 PCs were used to implement and distribute processing with 100 AIs, the processing would be nearly 100 times more efficient. Using time information can solve this problem. Oh, sorry. If there is one problem, if 99 AI are first, but one AI is slow, the remaining 99 needs to match the processing speed of the slowest AI. This is because without time information, this is because without time information, the time interval at which image arrive must be the same. Yeah. Oh. Using time information can solve this problem. Using time information, frames at arbitrary time intervals can be received and processed. Yeah. If we use time information, oh yeah, maybe. Oh, why? I don't know why. Okay. And merit to efficient processing can be performed at high speed using multiple PCs. This merit to is applicable not only when multiple PCs are used locally at hand, but also when multiple servers are used in the cloud. When implementing 100 AIs on the cloud by renting multiple servers, it is difficult to ensure that all servers have the same processing performance. It is also wasteful to match the performance to the one with the lowest performance. By using time information, processing can be performed even if the time intervals is arbitrary, making operations more efficient. And next, I will explain about proposed method 3, AELS team with time. Time information are added to AELS team network. The time information is the difference from the imaging time of the previous received image. Yeah, here is time information. When input, time information is appended to latent prime. When output, time information is appended to latent prime 2. This network added encoder layer to arrange same dimensions. And experiments. Creating a dataset for time training. Randomly drop 2 frames of 12 consecutive frames. The 13th frame of each data is used as a teacher frame. Since the image was captured at 20 FPS, the normal time information is information is 0.05 sec. If one image is missing, the time information of the next image is 0.10 seconds. If 2 consecutive images are missing, the time information of the next image will be 0.15 seconds. And evaluation. We evaluate 2 types of evaluation is executed. 1 frame missing. When 1 frame immediately before the teacher frame missing, time data of teacher frame is 0.10. As a result, AUROC is 0.947. And 2 consecutive frames missing. We calculate our AUROC, then 0.393. This is not good result. And summary, for the detection of timing anomalies in equipment that performs multiple patterns of repetitive operation, we focused on the issue of large anomaly scores for normal operation at pattern branch point. Two methods focusing on latent variables were proposed and evaluated together with conventional methods. There are no time information. ALSTM DZ and 2 PredNet L6. As a result, detection accuracies of 1 is 0.864, 2 is 0.902 were obtained, which are higher than those of conventional methods. And it's shown that there are multiple merits of using time information of imaging. It constructed a specific network using time information and showed that it is possible to detect missing frames. ALSTM with time. As a result, it shows an accuracy of 0.947 for a single missing frame. This is good result, but a low accuracy of 0.393 for 2 consecutive missing frames. One of the reasons for this is that the amount of data with 2 consecutive missing pieces in the training data was very slow. In the future, we will proceed with evaluations on the larger number of data sets. Thank you.